next lesson is about converting general form of a quadratic into standard form of a quadratic. Recall that a general form is ax squared bx and c. Standard form is a bracket x minus h squared and k, where h and k represent the vertex. In the past you learned about something called a perfect square trinomial. Looks like this: a squared, 2ab, and b squared. It makes, or is equal to, a binomial square, which for this general pattern would look like this: a plus b all squared. Now there's an analogy here. The a squared, 2ab, and b squared, if I made a equal x, it's a little more clear to see. X squared, 2b is a coefficient on x, linear term, and b squared. It's like the general form in a way. It's got a quadratic term, a linear term, and a constant term. This binomial square is like standard form in the sense of x minus a number squared. So if I'm given something that looks like this or this general form, in order to make it into standard form, I want to think about it as a binomial square, and I want to do something called completing the square. Completing the square is what this topic is often referred to as, going from general into standard form. The reason we would do it is that standard form is easy to graph and get information from. General form, not so much. So we need to recognize some patterns. Alright, so there is an analogy to general and standard form. Again, as I said, that's like general form, and this is like standard form. So what we are going to have a problem with is that you won't actually get a perfect square trinomial perfectly. We're going to make one. So what we have to recognize is that the constant term that we need, this value, constant, is generated from this coefficient. It's half of this value, see, half of 2b would be b, squared. That's how I form the constant term. Now watch these patterns here. This binomial square expands into this perfect square trinomial. Looking at the 9, 9 is half of the number 6 squared. Or this binomial square, it expands into this perfect square trinomial. How do I form 16? It's half of the number -8 squared. Now we're going to start from these and go in this direction, and the next problem is we're not actually going to get 9 and 16. We're going to have to craft them. So let's work through an example. Let's suppose we were given the general form y equals x squared, 6x, and 7, and we want to convert to standard form and then identify the vertex. Okay, well, 7 is not the number that we need. So what we do is we refer to 6, and what we need is half of that number 6 to be squared. Half of 6 is 3, 3 squared is 9. So what I'm going to do is I'm going to add 9 and subtract 9 from what I already have. So I'm not changing these at all. Notice those are completely unchanged. 7, I'm not going to ignore it, but I'm going to put it off to the end for processing later. What I just accomplished right here is making a perfect square trinomial. That perfect square trinomial can be written in factored form as x plus 3 all squared. Now, these two numbers here that are required because this number came with the question and this number was needed for balance, they get combined to make -2. And you'll notice we now have standard form with a vertex of -3, -2. So we've gone from general form to standard form by recognizing a pattern in the coefficient b. Now, sometimes you're going to get situations where a is not 1. What we do then is factor out a from the first two terms and then carry out the analysis the same. Let me give you an example to show you what this looks like. So I could be asked to write in standard form y equals 2x squared, 8x, and 1. ax squared, bx, and c. And the a is not 1. So I start by taking the 2 factor and removing it, leaving the remainders of x squared and 4x. Now, I'm going to tack the plus 1 out the end, because it's not the number that completes the square. You'll notice I left a little bit of a gap here. Over to the side, I'm going to write a note to myself. I need the number 1/2 of 4, that coefficient, to be squared. Well, 1/2 of 4 is 2, 2 squared is 4, so I am going to add 4 in, but I can't just add 4 without changing the expression. So I'll subtract it away as well. That keeps balance. What I've generated right here is a perfect square trinomial. And again, now that I've got the right values, I can write that as a binomial square, x plus 2. This sign follows this sign. Expand it to confirm your answer and just make sure you're doing it correctly. Don't forget the 2 and the y equals. Now, this number was needed for balance, but it's not part of my perfect square trinomial or the binomial square. So I have to multiply it by 2, and then don't forget the 1. And we have one more step to do. We just need to simplify what I've got there. There's my binomial square. There's my 2 multiplier out in front. This is -8, add 1, so taken together, minus 7. And the vertex of the standard form that I've just created is -2, comma, -7. That's the basic idea of how to take general form and convert to standard form. It requires lots of practice. I wish you well.